because here it includes a resistance wire AB. Okay, if you observe here, if you see here in this case, this is our resistance wire. माझी line cross आले, but this is a straight one. So yeah, this is our resistance wire AB. Okay, now this resistance wire AB having a uniform resistance per unit length. Okay, having a uniform resistance per unit of a length. Then that wire will be placed along with the side of this calibrated scale. Okay, now here this here uniform length, this wire which will be having a uniform resistance per unit of a length. Uniform resistance per unit of a length means what? म्हणजे त्याच्या पर युनिट लेंथचा रेजिस्टन्स काय आहे? सेम आहे, कॉन्स्टंट आहे. ओके, सो दॅट टाइप ऑफ अ वायर विल बी टेकन. Then that wire AB will be placed along with the side of this calibrated scale, such as a meter stick. Okay, then a current I, see here, therefore here a current I will be supplied from this battery B1. Okay, so now here this AB wire will be connected across this battery B1 and this resistance R1. Okay, so this is the primary circuit. So here this AB wire will be supplied to this battery B1. Therefore, this current of I ampere will be supplied from this battery B1, which will be flows to this wire AB. Now here, this current level, the current flowing through this wire AB will be controlled by this variable resistance R1. Okay, it will be controlled by a variable resistance R1. Then here, this is the primary circuit. Now at its secondary side, see here, this galvanometer G will be connected, means say here, this is the galvanometer, so that the one terminal of this galvanometer is connected to this resistance wire. Okay, it will be connected to this resistance wire via this sliding contact C. Okay, means here in this case, this is the sliding contact C, means we can say that it is also called as the jockey. Okay, means it is a variable where this over this wire AB. Okay, so the one of this terminal of this galvanometer is connected to this sliding contact C. Okay, and then the other terminal of this galvanometer will be connected to this switch S. Okay, this another terminal is connected to this switch S. Now see here, this switch can be connected, will be facilitates the two contacts. Okay, means here this switch S can be connected to our standard battery cell B2. Okay, it can be connected to our standard cell B2, or it can be connected to this another side of Vx, means nothing but the voltage, unknown voltage which is to be measured. Okay, unknown voltage which is to be measured. And here now here again here in this case, this is the resistance R2, and here this resistance R2 is used to protect this battery B2. Okay, to protect our standard cell B2 against the excessive current. Okay, means here this R1 will be used to control the current flowing through this wire AB. Similarly here, this R2 is used to protect against the excessive current this battery B2. Okay, so this is the construction, means this is the primary circuit and this is the secondary circuit, and nothing but we can say that this galvanometer G will be connected between this primary circuit and between this and this secondary circuit. Okay, so did you got this construction of potentiometer? Yes, did you got this construction of our potentiometer, how it will be constructed? This will be having the two circuits. One is the primary circuit, another is the secondary circuit. Primary circuit includes the resistance R and our battery B1, which will be supplied this current through this wire AB. And at its secondary side, there is a this standard cell B2 and this resistance R2 to protect this battery B2 against this excessive current. And here this is the unknown voltage which is to be measured, And for that purpose here, first of all, for the calibration purpose here, this switch S will be used. Okay, and then it will be switched over this unknown voltage side. Okay, and here this galvanometer will be connected between this primary side or between the sliding contact of this wire with the help of this sliding contact C or the jockey, and its another end is connected to the secondary circuit to this switch S. Okay, now see here, this is its construction. Then next is the calibration. So see here how it will be calibrated. So means here first of all here this galvanometer and its length will be calibrated before it will be switched to this unknown voltage side. Okay, which is to be measured. So first of all see here how this will be calibrated. So this calibration will be done. Okay, first of all here this calibration will be done by switching this setting this switch to connect to this standard cell to this galvanometer G. Okay, means first of all here for this calibration purpose this switch S will be connected towards this standard cell side. Okay, then here the sliding contact here, this slide contact C will be set or it will be adjusted to the position on this resistance wire. Okay, to the position on this resistance wire, which should have a voltage exactly equal to that of our standard cell. Okay, means here this voltage will be supplied through this battery B1, therefore the current will be flowing through this. Okay, therefore here the voltage will be dropped across this between these two terminals B and C, that is our VBC. Okay, and here this side will be this here switch will be thrown towards this set towards this standard cell B2. Okay, now here in this case this is the fixed one, so that now we are adjusted the value of this R1. We have adjusted the value of this R1 such that here in this case this galvanometer G will be indicates the zero or the null position. Now can you tell me here this galvanometer here in this case our galvanometer will be indicates the zero at which position or at which point here our galvanometer will be indicates the zero or null indication. Hmm? At a balanced condition, na. Always remember our galvanometer will be indicates the null indication or the zero indication when it is at a balanced condition. And at which position it will be at a balanced condition? When the voltage across both the sides will be becomes equal. Means what? Here when this voltage VBC that will be becomes equals to this voltage VB2, and that will be becomes equals to this voltage VB2. At that time here our galvanometer will be indicates the zero, and then with this resistance the resistance now wire now has the voltage drop per unit length. Okay, therefore see here when at a null position, that is when this voltage VBC will be becomes equals to VB2, then in that case the voltage drop per unit length across that length B